Hey guys, welcome to our senior secondary chemistry series. In this video, we're going to take a look at introduction to chemistry and nature of matter. Of course, we'll spend much time on nature of matter, so I've decided to call the entire video as nature of matter. So at the end of this video, here is what I expect you to be able to do. I expect you to have an idea of what chemistry is all about. Before we can go into other details, we'll first have to know what chemistry is. Then I expect you to be able to describe the three states of matter with examples and changes of states. This is grade 8 work, but that's where chemistry starts from, so we just have to revise from there. I also expect you to be able to define the kinetic theory. So we're going to learn about the kinetic theory, and I expect you to be able to define what it is. I also expect you to be able to define diffusion and the factors that affect its speed. So we're going to learn one occurrence of kinetic theory, or a natural phenomenon in which kinetic theory can be seen, which is called diffusion, and you should be able to define it and also explain the factors that affect its rate or speed. Let's get started. So what is chemistry? From the way it sounds, chemistry, you can tell that it has something to do with chemicals. But we're going to find out if that is true. So chemistry is defined as the branch of science that studies the chemical composition of matter. In senior secondary, we're going to learn about two other branches of science, and that is biology and physics. Of course, during exams, chemistry and physics are the ones that are called science, and biology is just biology. But as a branch of science, there are three: chemistry, physics, and biology. So physics studies the physical nature of matter, or the physical makeup of everything that we know. Then biology studies life, and chemistry studies the chemical composition or makeup of matter, the chemicals that makes up matter. Of course, the word chemical sounds like something dangerous, something which if swallowed can give you problems, but everything is made of chemicals. The phones you are holding is made of chemicals. Our bodies are made of chemicals. So matter is made of chemicals. So that's what we're going to be studying when we're studying chemistry. And what is matter, by the way? So matter is anything that occupies space and has mass. Of course, maybe we're introduced to what matter is in grade 8. So anything that occupies space and has mass is called matter. To give you an idea of what this means is, let's say you have a cup, an empty cup. So if you pour water in it, then the space that was in it has been occupied. So anything that can do that is called matter. But in essence, your space was, the space inside the cup was already occupied by air. So air is also matter because it occupied that space. And the space without any matter, without air, without gas, without gas, which is air, without solid, without liquid, is called a vacuum. So there are three states of matter: solid, liquid, and gas. So how do we tell which is which? So there are two properties that we use to tell which is which, and those are shape and volume. So volume is just the space occupied by an object, like the example that I had given where you pour water in a cup. That space that the water occupies is the volume. And shape, we all know what shape is. So we're going to use this table to analyze the difference between solid, liquid, and gas. So in this column, there are states, which are the three states of matter: solid, liquid, and gas. Here, we're going to analyze shape, then here volume, and here are the examples. So if we start solid, so solid have a fixed shape and a fixed volume, which means their shape and their volume don't change. Examples of solid are ice, charcoal, and metal. So I'll start with metal. The volume and shape of a metal doesn't change, of course, if you don't hammer it or if you don't heat it. And also for charcoal, it's the same. If it's not heated or anything, the shape will be the same and the volume will be the same. For ice, it's the same. Of course, you can say no, it will melt and the volume might change or the shape might change. But if it's at a constant temperature, then it cannot change. What about liquids? So liquids have unfixed shape and fixed volume, unfixed shape and fixed volume. So their shape changes. Water changes shape and now, but the volume is still the same. 20 liters of water is 20 liters of water. It won't change unless maybe you do something else. Other without external interference, the volume will be the same. Then what about gases? Gases have got unfixed shape and unfixed volume, meaning that for gases, their shape always changes and the same applies for their volume. Oh, by the way, examples of liquids are hot and blood. Examples of gases are oxygen, carbon dioxide, nitrogen, and tear gas, the famous one. Yeah. So the three states of matter can change. So matter can change from one form to another, from solid to liquid, or from liquid to solid, just like that. So let's start that. So let's say I've got a solid here. Let's say an ice. It can change if you heat it, and that process where you heat an ice, then it changes to a liquid. To know it's called melting. So the change of state from solid to liquid is called melting. Solid to liquid is melting. Let's say now we have water, then we heat this water. So the liquid will change into a gas. So liquid will change into a gas, and this process is called evaporation. Another process that can occur is the gas change to liquid. So you have got a gas, then change to liquid. How can this happen? Let me give an example. Let's say you are heating water in a pot. So when it has started to boil, then you press your arm somewhere where the steam is passing. That steam actually is gas. So when you heat water, the steam that comes, that's the gas. So it means it's water in the gaseous state. So going back to our example, you press your hand or on the passage of the steam, then you see that your hand will become watery. So what has happened? The steam has been converted back to a liquid. So the change of state from gas to liquid is called condensation. So your gas has condensed. Another scenario is where a liquid is changed to a solid. You have got water in a cup, you put it in a fridge, it becomes an ice. So the change of state from liquid to solid is called freezing. There's now one rare case where a solid changes to a gas. A solid changes into a gas. Just imagine you have a charcoal, then it turns into a gas. That's like magic. Or a gas changes into a solid. So there is a gas here, then it becomes something with a fixed shape and fixed volume. So such a process where, for example, a gas changes into a solid is called sublimation. Or a solid changes into a gas, it is also called sublimation. So is there a thing which sublimes? Yes, there's what is called ammonium chloride and carbon dioxide. There's carbon dioxide can change from gas to solid. So it's usually in its solid state, it's called dry ice. So I will give later I will give you the same information just for your notes. So this is the additional information on the changes of state. So the other name for freezing is called solidification. So if you are freezing something, you are solidifying. So these are just terminology used in chemistry, so that at some point when you are studying, then you find the word solidification. You shouldn't get confused, just know that it is freezing. The temperature at which a liquid freezes or solidifies is called freezing point. Water has a freezing point of 0 degrees Celsius. So when the temperature reaches 0 degrees Celsius, water in its liquid state will turn into ice. The other word for evaporation is vaporization. The gaseous state formed after vaporization is called vapor. So that steam is also called vapor. The temperature at which a liquid vaporizes is called boiling point. Water has a boiling point of 100 degrees Celsius. So when you're heating your water and you see it turning into steam or steam forming, just know that you have reached 100 degrees Celsius, because that's the boiling point of water, of pure water, by the way. I'm going to explain that in other topics, or why I emphasize on pure water. And finally, an example of a substance that sublimes is ammonium. Sorry for that. An example of a substance that sublimes is ammonium chloride. Ammonium chloride. Words like ammonium chloride, you're going to understand them later what they mean. This is a salt. But don't worry what a salt is. Not that salt which you put in relish when cooking, no? Yeah, but ammonium chloride is a salt. So this one can change from solid to gas. And also there is this dry ice, like I explained, the solid form of carbon dioxide. So carbon dioxide can change from gaseous, from being a gas to being a solid, and from being a solid to being a gas. When it's a solid, it's called dry ice. So everything I've looked at so far is about matter, but chemistry is concerned or is interested in the chemicals that makes up matter. So we're going to dive deep into the inside of matter so that we know the chemicals that makes up matter. So one idea that is going to help us understand the chemicals that makes up matter is called the kinetic theory. So a theory is just an idea that has been observed in nature and needs more information for it to be taken, or for us to conclude that that is how nature works. So the kinetic theory states that matter is made up of small, discrete particles. The key words here are small and discrete. So discrete means, in this context, it means separate or independent. So matter is made up of small, separate or independent particles. So the phone you're holding or the computer you're using to watch this video, it's, of course, it's a solid, and it appears to be one thing, but in reality, or according to the kinetic theory, it's made up of very small, separate particles. So how did people develop this? How did they come up with this kinetic theory? So there were some observations they saw in nature, things they saw in nature. One of them was what is called diffusion. So what is diffusion? So diffusion is movement of particles from an area where they are in high concentration to an area of low concentration. We have all observed diffusion. We all know what diffusion is. Maybe we just did not know the name or what it is called in science, but diffusion is just the movement of particles from where they are in high concentration to an area of low concentration. A very good example is, let's say at point A, there's something that has gone bad, maybe food that has gone bad. Then you are standing at point B. You smell that something has gone bad. How did it happen? You're not in contact with the thing that has gone bad. So what's happening is the particles of air at the thing that has gone bad, they are highly concentrated. Then they will be moving to where they are in low concentration. That is where you are. So that process is what is called diffusion. When you spray your perfume, you spray your body, but maybe your whole house will have that fragrance. So how did that happen? The particles of perfume have moved from where you have sprayed to all the corners of the house. So particles move from where they are highly concentrated to where they are low in concentration. So that's what diffusion is. Another special word, scientific word that is used to describe the diffusion of water is called osmosis, and is defined as the diffusion of water particles across a membrane. A membrane is like a sieve, or inyanja, maybe we can say a safer, something that acts as a barrier between two sides but only allows certain things to pass through it. That's a membrane. So osmosis is the diffusion of water particles across a membrane. Diffusion can be anything, but osmosis is only concerned with water and a membrane. So we're going to take a look at factors that determine the rate of diffusion. So the rate of diffusion is the speed of diffusion. So if that thing that went bad, how long does it take for it to reach you? So that's what we're going to determine. That's what we're going to learn. What determines the speed at which it reaches you, or how fast it reaches you. So the first factor that determines the rate of diffusion is temperature. And it says the higher the temperature, the greater the rate of diffusion. So if it is hot, things move faster than when it's cold. How is that so? Particles have what is called moving energy or kinetic energy. And temperature increases the kinetic energy. An increased kinetic energy means something moves faster. And that's why an increased temperature results in the greater rate of diffusion. Another factor that determines the rate of diffusion is particle size. So they say the smaller the particle, the greater the rate of diffusion. Small particles move faster than bigger particles. They say we've got these two particles here. So smaller particles move faster than bigger particles. Though my animation is a little bit lagged, but anyway, it's okay, you get the point. So another factor is concentration. So it says the higher the concentration, the greater the rate of diffusion. What concentration means in the kitchen language, I like to give kitchen examples when it comes to chemistry, because that's where most of it happens. So if you put too much sugar in water, it means the sugar has higher concentration, but less sugar, it means it has less concentration. So it says the higher the concentration, the greater the rate of diffusion. When you are spraying your body with perfume, if you spray yourself like too much with a lot of it, then of course the time to take for the whole house to have that fragrance is going to be less as when you have sprayed less perfume. So the higher the concentration, the greater the rate of diffusion. In short, the more you spray yourself, the faster the particles move to all the corners of the house. Another observation that has been made in nature, just like diffusion, is what is called Brownian motion. So this came about when a certain man in the days of old carried out an experiment in which he had put a light bulb, a glass cell. By the way, a glass cell is just like a gas cap. You can open it and close it so that you trap things inside it for your experiments. So he had trapped some smoke in it so that he observes the behavior of the smoke particles, and of course the same particles if smoke had particles. Then he took a microscope. The job of the microscope, or the function of the microscope, was to help him see the smoke particles. Since the kinetic theory says that matter is made up of small discrete particles, so he wanted to see the small things that make up matter, and since he couldn't see with naked eyes, he had to use a microscope. That's what the microscope does. It helps us see those small things which we cannot see by making them bigger. So the function of the microscope is to enlarge smaller things, or to make smaller things look bigger. Then the function of the light bulb here was to illuminate, or to provide light to the smoke. So when he observed through his microscope, he saw the smoke particles. They were ever moving in random motion. So Brownian motion is the term used for the continuous random motion of particles, particularly particles of liquids and gases. So this has been observed in liquids and gases. And the continuous random motion, what it means is continuous, the motion is ever happening. They are always moving. And random, the direction they take, or the direction they take when they are moving, is, you cannot predict it. It's ever changing. So that's what Brownian motion is all about. But the question is, why is it that they are always moving? Why is it that they are always doing like this? So he realized that maybe inside the glass cell there was also air. So the particles of air, which he couldn't see, were colliding, or were bumping into the particles of smoke. So that collision made them to be moving apart or to becoming closer. So in short, the motion might be possible because of other particles that were present according to Brownian motion. So what to take here is you have to have an idea of this experiment, and also the definition of Brownian motion, and the fact that Brownian motion supports the kinetic theory of matter. So this marks the end of this video. Make sure you like, share, and subscribe. The next video, we're going to take a look at how to see solid, liquids, and gases using the kinetic theory. For now, happy solving.